Concept of generics is one of the most complex concepts in Rust, and in this video I will oversimplify everything for you so you can easily understand it without giving you real world examples that can be very complex, and maybe in the next video we will go to that part. Now at first we will just see this is my struct. It's very simple. Take two numbers and you can create a new struct with this new method, and you can add two numbers together, and we can see the test right here. We are adding 1 plus 1 and it would just return it. So there is nothing here generic. Now the exact same struct that take x and y, I just made it generic. So right now we have these tests. It still does the same thing. Take 1 and 2. You can just sum numbers and it will be working just fine. But the difference is right now we can take different types of numbers. We can take U64, U32, and that will be useful in real world examples. Maybe it could be a bit complex, like you have an ID of a user. It can be a string or it can be an array of numbers like U32, like this one. In these two examples, the ID can be a string, a random string like this, or it can be a vector of random numbers. So what if you want to create a struct that can accept something like this? So in this case, you can create a struct, a generic struct that can be used in both cases. So that's why we use generics. But in this example, we will not go through this. We will do something simpler. So the main idea about having generic, it is this right here, this line. We add this part where my number can have the following features. So these features are, so for example, we can subtract, we can add, we can copy, it can be a value of 0. So we give it specific properties without giving it a specific type, and you can imagine how that applies to the ID example that we talked about, which can be a string and it can be a vector, but both can have the same feature without defining the exact type. So this is the main idea that we need to focus on. Going back to the syntax, we have this angle brackets where we define something generic. We can call it A, we can call it B, we can call it T, A, B, C, D, anything that you like. It's preferred to be start with capital letter. And then we move to the implementation, which we implement this two functions or a function and a method. Just like in the basic example that we have, we implemented this, and it was quite simple. We strictly define what we want to input here. But in this example, in the generic, we put this generic that we define the attributes of it, but we didn't restrict the type of it. If you look at it closely, it is a very simple concept actually. Just that Rust come with very specific types, and instead of using their type, I can do my own type. I could just say x32 instead of u32. So I can have my own type. Now, let's just say I just have a struct with very huge input. In this example, we have A, B, C, D. We have too many types, and we have some of them, they already use a built-in type, but some of them, they use our own types. That can get even more complex, and right here, when we define it, we should put all of this. Just like this, you can see it gets very messy, very annoying, and you can make more mistakes when it looks like this. So you can imagine when we have big projects. So this is the first problem that we have with the current system. The second problem is, what if I want to create another struct that have exactly the same thing, except maybe it has one extra field relative to this. So why should I rewrite all of these things and add one more field to it? Why I cannot just inherit all of this and then just add my extra fields to it? So to solve these two problems, we have one concept we call it traits, or it can be also called config. And this is a minimal example where I used config and I'm still having the X and Y. They are two fields, but this is not a real world example. You should remember this. And the syntax is a little bit different. So you can see we have this T config and then we define T right here, and we can use T and we can inherit from T. So this is the inherit that we're talking about. And you can see this can get much nicer because if we have too many fields, this implement can be very annoying like this. You can imagine without the trait, we will have in this way, which will actually ruin our code and it will look very ugly. And going further with the syntax, we will inherit from T my number, just like you can see, or we can inherit this, the other number, as you wish. And when we are using it, now this is very interesting. We can create a new struct and we can implement config to this struct and we can put it right here again instead of using it in this way, which is can be very long. Now, if we want to create a new struct, we can do it just like this. And as you can see, we simply inherit from config and we can just implement it to our new struct.